Good afternoon, BMS Math students. We are continuing with Unit 2, Moving Straight Ahead. Today we'll be talking about Lesson 2, Writing Expressions and Equations. Our essential question for the day is, how can I translate a verbal expression or equation into an algebraic expression or equation? First, let's talk about things that may happen in the real world. Let's say that you are exploring a cave in which rock formations called stalagmites grow up from the cave floor. The tour guide informs you that the tallest stalagmite in the cave is in a pool of water 55 feet deep, and the distance between the tip of the stalagmite and the surface of the water is 41 feet. How tall is the stalagmite? You'll find the answer in example 3. There's where we'll talk a little more in detail about this example. Alright, first some things that we need to know, some vocabulary terms that we need to know when translating phrases and sentences. To solve real-world problems, you need to translate verbal phrases and sentences into variable expressions and equations. Verbal meaning written in words, and then we want to change them to expressions, our numbers, and our equations. You want to look for keywords that indicate if it's addition, subtraction, multiplication, or division. Here we have some examples of those. For addition, we have plus, the sum of, increased by, total, more than, and added to. These are just some of them. I'm going to put a star next to more than because we're going to talk about that one a little in more detail in just a second. Then we have subtraction. This is minus, the difference of, decreased by, fewer than, less than, and subtracted from. Again, I'm going to put a star next to less than. And if I'm going too fast, you can certainly pause the video at any time to write these down. Then we have multiplication, which is times, the product of, multiplied by, of, and division, which is divided by the quotient of. Down here we have more than and less than. They are very special cases in which you switch the order of the terms. You need to remember, with more than and less than, there should be a little light bulb that goes off in your head every time you see that this is a special case, so I have to do something differently. And we'll be talking about that in some of our examples. Alright, let's look at example 1, translating verbal expressions. Alright, anytime I'm doing this, the first thing I do is I go and I look for my keywords. I have a number, okay? So I have a number. I'm going to underline that. And this number is increased. Well, if I remember from my words, increased means added. That's addition by the number 5. Well, anytime I see a number, the word a number, that means a variable. It's a number that's unknown. So I'm going to put a variable here. Any letter will do. I'm just going to deal with x. So I have a number, which is going to be x, added, addition, because I'm using increase, by 5. So I would write that just as I read it, a number, which I chose x, increase by, which means addition, 5. And that's how I would write it. And that is my answer. I don't do anything else to it. Okay? Alright, let's look at the second one. 7 less than. And if you remember, I said there should be a light bulb that goes off, an alarm in your head when I see less than. So I'm going to just box that in and put a little star next to it. I do know less than means I'm subtracting. And here this is again a number. Well, I'm going to put this time in for my number, my variable. Now, you remember when we said more than and less than is a special case, and that it's going to flip the order. So what's going to happen is that this front number and this after the less than, they're going to switch places. Okay, so the 7 is going to go behind the less than, and my variable is going to go in front of the less than, so that it will look like a number minus 7. Okay, so those two things just switch places. And that always happens with less than and more than. All right, let's look at the third. Here we go again. We have 3 more than. Well, more than in this case means I'm adding, and then I have twice a number. Well, twice a number, I know a number means it's going to be a variable, so let's write x. If I have twice of something, that is 2 times. So this is going to be represented by 2 times, and the multiplication sign is hidden there, a number, x. So I remember with more than, I have to switch these two. So this goes behind the plus sign, this goes in front of the plus sign. So I have 2 times my number. More than means I'm adding, and then 3. And then the last one, 4 decreased by. Well, I know decreased by is subtraction. The quotient, and quotient was dividing of a number, pick a variable, any variable, and 7. So let's write this out. I'm not dealing with less than or more than, so I don't have to switch anything. So I have 4 minus the quotient of a number and 7. Well, let's put this in parentheses. Let's say the quotient of a number and 7. So that's going to be my number divided by 7. Now, you don't necessarily have to put it in parentheses because division comes before subtraction, but I like putting it in parentheses just so I don't get myself confused. Okay? Example 2. Now we're translating verbal equations. Before we were translating expressions, which means it did not have an equal sign. There was nothing to solve. If I have an equation, that means I can solve something. But here we're just translating. We're not trying to solve it. We just want to write it out in numbers, what it would look like. So here's my hint down here that's going to be really helpful. The key words is and equals are represented with the equal sign. So anytime you see is or equals, that's going to have my equal sign there. All right, so let's look at this first one. I have 16 increased by, which is adding. A number, I'm going to put a variable there. Is, which we just read, is an equal sign, 27. So once I've kind of translated my way through this, now I'm just going to put it all together in numbers. I have 16 increased, I was adding a number, which is my variable, equals 27. So as long as I'm not dealing with more than or less than, I'm really just writing it. I start on the left-hand side, move over to the right, and just write it as I see it. All right, let's look at B. The difference, which I'm going to be subtracting, of twice a number, so that means 2 times my variable, and 3 equals -4. So the difference of twice a number and 3. This and is where my subtraction sign is going to go. So I'm going to have twice a number minus 3 equals -4. All right, C. The product, which means multiplication, and I'm going to represent that with the little dot, because now we're dealing with variables, and sometimes the multiplication sign of an x can get confused with a variable, so let's not write that as a multiplication sign anymore. The product of 1/2 and a number is 36. So let's say that my number is n. So the product of half and a number, so that's going to be 1/2 times a number, and remember, since there's nothing in between the 1/2 and the n, it's automatically assumed that that's multiplication. Is, which means equals, 36. All right, D. -3 is equal to, so that's equals, twice, so 2 times. Now here it says I need to take the sum of a number and 2 before I multiply it by this twice here, 2 times. So that means that anytime you have this, I'm going to have to put this in parentheses because I want my number, which is I'll represent as x, and 2, I want to do the sum of this before I multiply. And the only way I can do that is through parentheses, through PEMDAS. So it's going to look like -3 is equal to 2 times the sum of a number and 2. So that way I add x and 2 before I multiply here. Be careful for things like this when it says the sum of a number and 2, but you're supposed to do something else to it as well. Alright, here is from the very beginning when we talked about the caves and we were exploring the stalagmites, and it wanted to know how tall the stalagmite was. Well, here is how we would find this answer. We would take the information that they gave us and write it as an equation. So to find the height of the stalagmite described at the beginning of the presentation, you can write and solve an equation. First, you write a verbal model. So it says, let h represent the height of the stalagmite. So here is height. That's what I don't know. That's the unknown. That's my number. Plus the distance between the tip of the stalagmite and the water surface, and that was given to us in the problem earlier in the slides, equals the depth of water, which was 55. So I would take this and write it as an equation, and then later we'll learn how to solve that. Alright, now it is your turn. You are going to write the verbal phrase or sentence as an expression or equation. And this time they're going to tell you that n is going to represent the number. So anytime you see a number, you're going to write n. Now pause the video and complete 1 through 5.